All right, welcome back everyone. Let's go ahead and walk through the solutions to the Now You Try problems where we're graphing functions that are quadratics with a special form for special factorization. We're going to find the y-intercept, its mirror, the x-intercepts, the vertex, and 2 additional points, and graph the function. Our first function that we look at for part A is f of x equals 25 minus x squared. Let's go ahead and, in this case, I'll just start with plugging in 0. F of 0 equals 25. So we have the point 0, 25 is the y-intercept. This is a special case where this is also going to be the vertex and the y-intercept's mirror. That's because the b value is 0. So if I do the x sub v, right, the x value of the vertex, that equals negative 0 over 2 times negative 1. This one's backwards, so a equals, if we rewrote this as negative x squared plus 25, that's an equivalent expression, and we see a equals negative 1. It's the coefficient of x squared, b equals 0, and c equals 25. So the x value of the vertex is 0, meaning it's also the y-intercept. All right, so let's find the x-intercepts. We set y equal to 0, so 0 equals 25 minus x squared. Factoring this, we get 0 equals 5 minus x times 5 plus x. So we get 5 minus x equals 0, or 5 plus x equals 0. Solving these, we get x equals 5, or x equals negative 5. So our x-intercepts are the points 5, 0, and negative 5, 0. I think with this, we can get a pretty good graph, and then we'll find a couple of more points to round it out a little bit. Get some axes going. I want to think about where I'm at. 0, 25 is the vertex. This is downward facing. So if I put 25 up here, we go, maybe it's just easiest to make this a small graph. 1, 2, 3, 4, 5, and say that the x-axis is here and that we're going by 5s. Then I'll put 5 out here. So 1 in the x direction seems to make sense. I'll have negative 5, 0, and positive 5, 0. The y-intercept slash vertex slash y-intercept's mirror is 0, 25. And just to get a little bit more detail to this graph, let's find a couple other points on it. Let's see. Let's plug in x is 2 and negative 2. So f of negative 2 equals 25 minus negative 2 squared. This is 25 minus 4 equals 21. It's going to be just above the 20 line. And these are symmetrical about the vertex. And with this, we can go ahead and draw in our parabola. Go ahead and label it as y equals f of x. And that's it, we're good. Got all of our key points on here. Got the vertex, the y-intercept, its mirror, a couple of extra points, the x-intercepts, and that's everything. Let's go ahead and move on to part B. We have g of x equals 4x squared plus 4x plus 1. We'll start with the vertex. So the x value of the vertex is going to be negative 4 over 2 times 4. This is negative 1/2 when we reduce here. G of negative 1/2. It's going to be a little tedious, but not too bad. 4 times negative 1/2 squared plus 4 times negative 1/2 plus 1. This will give us 4 times 1/4 minus 4 times 1/2 is 2. It's a minus because we have a plus and a minus being multiplied, and a plus 1. So this is going to 4 times 1/4 is 1, minus 2 plus 1 is 0. So we have the x value of the vertex, or I'm sorry, the y value of the vertex is 0. Our vertex is the point negative 1/2, comma 0. And this is going to be also the only x-intercept. First, we see that it is an x-intercept because the y value is 0. And let's look at this graphically so we can kind of see in that manner why it's the only x-intercept. But let's do that in a second. Let's find the y-intercept in its mirror real quick. The y-intercept, we plug in 0 for x, and we get a 1 out. And so the vertex is negative at negative 1/2 for x, so the mirror to the y-intercept is going to be negative 1, comma 1. All right, so we want to make sure we can plot those points and the vertex. Go ahead and get our graph set up here. Coordinate plane. Actually, I want to move this right a little bit. There's my eraser. X, Y, let's put 1 right here, 2 here. So 1, 2, and then we'll put negative 1, negative 2. All right, we've got pretty small numbers for all of this, so I'm just trying to zoom in a bit. And so we can plot the vertex, negative 1/2, comma 0. And then we have the point 0, 1, and the point negative 1, 1. Move this to the right a bit more here. Here's positive 1. And so if we think about the symmetry here, and we think about the point negative 1/2, 0, that's the vertex, if we had another x-intercept anywhere, it would throw off the symmetry. It wouldn't work because it would have to be on the other side of the vertex symmetrically, but the vertex is this x-intercept. So that has to be the only x-intercept here. Let's go ahead and find a couple more points. Let's plug in, let's try and get negative 1.5 and positive 1/2 here. So negative 3/2 over here. Let's see, what's g of 1/2? This is going to be 4 times 1/2 squared plus 4 times 1/2 plus 1. This will give us 4 times 1/4 plus 2 plus 1. 4 times 1/4 is 1, plus 2 is 3, plus 1 is 4. So at 1/2 we should be all the way up at 4. So that's maybe a bit higher than I want to graph here. Or I can just change my scale. Because, sometimes we have to erase and change things up a bit. So I'm going to change my scale so that this all fits nicely. So I'll make this 2 and this 4 up here. So my y-intercept at 0, 1 is here. And then negative 1, 1 is going to be here now. Negative 1, comma 1. And then I have 1/2, comma 4. Should be symmetrical with negative 3/2, comma 4. And now we can go ahead and draw our parabola through all 5 points. And that's it. All right. Nice job, everyone. Let's get a little on my x-axis. That disappeared. That's everything for this video. Thanks so much for watching, and we will see you soon. Have a great day.